Okay, so this is a fun week, even though I know that some of you probably aren't super worried about it because this stuff is not going to be on your term test 3, which is this Friday, but this stuff will be on your term test, or maybe will be on your term test. Let's say for now, tentatively, will be on term test 4. Let me get the polls up here. Okay, so we're doing conditional probability. And let me tell you, conditional probability always gave me a hell of a time when I was a young grasshopper. Remember in high school math, this is literally the only thing I didn't understand. I was just like, I have no idea how conditional probability works. Is only 8 to 10, Rafid, I'm not certain what you're asking there. Chapter 8 to 10. Oh, weeks 8 to 10. Yes, maybe.
I mean, it's from the beginning of the counting chapter away till the total probability.
Yeah, so
last week.
Yeah, so I think that is weeks 8 to 10, right? Like there's 3 weeks covered. Yeah, so I guess that's right. Seems right. Yeah, for sure. Yeah, I was confused by that. I was like, oh, that's yeah, no, everything is the same old, right? Like, yeah, no worries. We're gonna, every single of the term tests will be the exact same, everyone. So don't, worry about that. Like the format will be the same, the times will be the same. That will never change, right? Right, exactly, and thank you. Does what matter for order, Connie? The coin. That's a tough question. Sure. But so for example, how many ways are there of flipping 2 coins, right? Like that's a question that we can just answer right now. Is if I flip 2 coins, how many ways can you flip the first coin? How many ways can you flip the second coin? So how many ways are there? And this is an open coin, like anyone. Right. Yeah, so there is 4, and we can say that one kind of publicly. So there's 4 ways. And notice that when we say there's 4 ways, we're saying heads, tails, and tails, heads is different, right? So in that case, like we are saying that order matters in the order in which the heads and tails can come up. Yeah, so your first one isn't right either. Yeah. Okay, so I'm going to do 30 seconds. F would be at least one of the misheads, yeah. At least one, right? That's important. Don't forget that. But yes, that is the correct order. Okay, so let's take a look at this. Kinda. It's similar to the the Monty Hall problem, Ariana, which is kind of what I assume you're talking about with the goats and the cars and such. Okay, so we're leaning towards C, followed a little bit by B and A. Okay, so C is not the correct answer. So yeah, so this is kind of an important one. And I think that like once we do this question, it'll clarify a lot. And then that way, when we get into more of the advanced problems, we can, hopefully things will be a little bit clearer. So here, let's go to this. Let me move this down. I've just copied it into here because I'm going to need it later, you can imagine. All right, so what do we know? So we have, this is question 1. Okay, so what did we do? So we flipped 2 coins, and let's just do this. What are all the options? If I flip 2 coins, heads and tails is what can come up. What are all of the possible outcomes that can happen just if I flip 2 coins? So what can we get? Heads, heads, tails. Yeah, okay, exactly. Heads, heads. I'm going to write them in a slightly different order, but of course, that doesn't matter. Heads, tails, tails, heads, tails, tails, right? Does everyone agree? Those are the 4 things you can do, right? Okay, so what I want to do now is I want to say, all right, we're told, let's just name things. So E is going to be that both outcomes are heads. Okay, and F is going to be at least one is heads. At least one coin is heads. Okay, now the way that I want to do this first is just straight up kind of intuitively, how do we do this? And then we'll worry about kind of the mathematically of how I actually like compute this. Like if you didn't know how to do this intuitively, how would we just go ahead and rely on the mathematics? Okay, so it gives us a little bit of intuition. So we're saying, what is the probability of E given F, right? So the probability of E given F, right? So probability of 2 heads given, right? And that's what the vertical bar means, right? You can think of the vertical bar there as saying given. So the probability of 2 heads given that there is at least 1 head. Okay, now here's the way that I want you to think about this, okay? Here's the important part. When you say, given that there is at least 1 head, what you're saying is, whatever, there's some amount of information that you already know ahead of time, right? You have been told that you've flipped these ahead of time, you've checked the dice, or sorry, you've checked the coins, and what you've learned is that at least one of them is a heads. So you're already in that frame of information. So let's go back up and let's look at the 4 possible things that 4 possible coin flips that could have happened. Heads, 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 tails, tails, heads, and tails, tails. These 3 are all where at least one of the coins is heads, right? Does that make sense? Does everyone agree? Right? So we've been told that we are in the yellow, okay? Maybe let me even make this more clear. So once we're told that at least one of the coins is tails, we're going to throw out tails, tails. We know that event isn't even possible anymore because it doesn't have at least 1 head, right? We're in a situation where we know that our coin flip must include at least 1 head. So we throw away the tails, tails, and we are now only in the situation where the yellow boxes matter. Now I'm going to say to you, right, we're looking for the probability of 2 heads. Well, how many events in here have 2 heads? Exactly, just one of them, right? And so that means 1 out of 3. So this is the only event that has 2 heads, and that means the probability should be 1/3. Okay, so what we do is we look at our event space and we throw away everything that doesn't match the given statement, right? We say, given that there is at least 1 head, those are the things that we're interested in, and we throw everything else away. And then we say, okay, what is the probability in that new set that our event occurs. Okay. Now, if we wanted to actually do this mathematically, like let's say you didn't have that level of intuition, or you couldn't draw it out because there were too many possible events, then what you would do is you'd actually use the definition, right? And the definition is the probability of E intersect F divided by the probability of F, right? Now, again, this case is relatively small. There are only 4 things in our event space. We can write each of these out explicitly, right? We can say what E is, right? E is heads, 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 tails, tails, heads, right? F is just heads, heads, and E intersect F is therefore just heads, heads. And if I take all those probabilities, right, our coins are fair. So the probabilities, the whole thing is equiprobable. If I plug all of those numbers in, well, the probability of E intersect F is 1 out of 4. And the probability of F, wait a second, what do I want here? Did I screw up? Oh, sorry. I switched these, didn't I? I wrote these backwards. This one is F, this one is E. Sorry. Yeah, sorry. I put them backwards. I was being silly. So the probability of E intersect F is 1/4, and the probability of F is 3/4. And you can see that the kind of the 4s cancel out here, and we get the same answer, right? We get 1/3 that way. So sorry, I wrote my E's and F backward, but I fixed it now. Okay, so we get these quotient, this division of 1/4 by 3/4, and then the divided by 4 part cancels out, and that just gives us 1/3. So you can use both ways. The intuitive approach is very nice, especially when your sample size is relatively small or when you can draw it. So for example, when we have dice or coins, that's very nice. But sometimes you have to go through and it's too hard and it's too complicated, and you just kind of have to compute these things this way. Yeah, it's always intersection. Always, always, always intersection. What if F is at most 1 head? Then it would be an independent event. Okay, so this is a really great question. Or at most 1 head. So let's try it. Okay, so what if F is at most 1 head? So if we change it to F equals, let's use a different letter, right? Just so that we don't confuse it. So F is at most 1 head. Then that's what? So that's tails, tails, heads, tails, and tails, heads, right? And so now I assume that we still want the probability of 2 heads, right? So it's not even that they're independent, it's that these are mutually exclusive, right? So the probability of E intersect G is the probability of the empty set, which is 0. Right? So it's not that the probability, it's not that they're independent, it's that the events are actually mutually exclusive. So when I say, what is the probability of, I don't know, what do I want to say? What are like 2 impossible things that could happen in real life? What is the probability that it's raining outside given that pigs can fly? Right? It's just 0. There's no probability of this because those 2 events are completely and totally, they're mutually exclusive. They're unrelated. Though I guess, yeah, we could say that. That's not maybe the best analogy. So I have a question. Okay, so Ahmed, you asked first, so let me answer your question. So why is it out of 4? So if I just said, what is the probability, say, of E, right? We would divide the number of events in E, which is 1, divided by this total number of events that could happen, right? And that's why it's out of 4, because there are 4 events in total. Does that make sense? Okay, cool. And yeah, Jeremiah said that. So Jeremiah, sorry, I didn't see your answer, but absolutely correct. At most is the opposite of at least, right? So when you say at most 1, that means 0 or 1. Okay, so Agam, does that make sense? Like they're actually not independent, because if they were independent, then the conditional probability is just the probability of E. But in this case, we actually get 0 here, and this is not 0, right? So they're not independent. They're actually just mutually exclusive. Okay. But yeah, no, that's an interesting question. And again, it's really nice, just take a little twist on the question and see what it is you can say. And yeah, I mean, that's exactly the right sort of thing to do, is to see what sort of, if we make small twists, how can we change it? Okay. So again, I want you to, if you need to maybe take a picture of this, we're going to do a dice question. We're going to roll 2 dice. So if you need to take a picture of that, do it. Otherwise, just write out the table yourself. But our next question is going to be, like I said, it's going to be a dice question. So let's give it a shot here. All right, so there we go. Let me restart the poll. So what do you mean by try, Brandon? I mean, you definitely can try it, but are you asking whether you can say the answer out loud? Yeah, I mean, it's a challenge question at the bottom, right? Just go ahead and try it. And you can always try it, right? I mean, you don't have to ask me if you want to try to solve something. You should always just do it. I mean, as long as you've answered the original question first, right? Curdy, I think you might have got them backwards. Yeah, Brandon, exactly. Good. Gerber tab shouldn't be more than one, right? Okay, 30 seconds here. And again, when we take this one up, I will do it both kind of like, we'll use the chart that we drew, and then we'll do it the intuitive way, right? Or sorry, that is the intuitive way. Then we'll do it kind of the algebraic way, where we actually write out what the events are and enumerate them and see, what our probabilities are. Okay. All right, so here are the results. Phenomenal. The majority of the classes said C. And I mean, this is what I want to see, right? Because I mean, we were kind of split on the coin flipping, and then immediately we go to a harder question and the majority of the class gets it right. So I think that that's really cool. I love to see that. Let's take it up now. Okay, so again, maybe let me just kind of do a little bit of writing here just to remind us of what, the question actually said. So A was the sum is 6. The sum is 6. B is the first dice, right? Only the first dice, or first die. First die is odd. Okay. So, and what do we want? We want the probability of B given A, right? So we're told that A has already happened, right? So from an intuitive viewpoint, we're told that A has already happened. So let's go through here and let's find all the events in which A has already occurred. And I'm going to circle them in yellow, right? So we're told that we already know that the sum is 6. Now, what I want you to do is go through these things that I've circled yellow. How many of them, in how many of them is the first die odd? 3. Does everyone agree? Right? So let me maybe put a little star beside them. This one, the die is odd. This one, the die is odd. This one, the die is odd, right? So what should our answer be? What is the probability of the blue things if they live in the yellow things? 3/5. Exactly. Jack, Curdy, Josefa, perfect, everyone. So the probability, just based off of our little chart here, the probability of B given A should be 3/5. Okay. Now, if we actually do it algebraically, we need to write everything all out, right? So first of all, let's write out our formula just so that we know what we have to compute. So the probability of B given A is B intersect A. And of course, that order doesn't matter, right? If you had written it A intersect B, it's the same thing, divided by the probability of A. Okay, so we need to compute the probability of A, and we have to do the probability of B intersect A. Okay, so B intersect A, right? Again, so this says the sum is 6 and the first die is odd. Sum is 6 and first die is odd. And the reality is that even if this was a really big sample space, you could probably just write this one out yourself, right? You would say, okay, so the first die has to be odd. So if I make the first die 1, what does the second one need to be 6? Oh, okay, it needs to be 5. And then if I let this be 3, that's 3. And then if I let this one be 5, that's 1, right? Okay, sweet. And there you are. So even if the sample space was really, really big, you can still enumerate this intersection, right? For the total outcomes for that, it would be the total outcomes of A occurring. Yeah, exactly. And that's why we divide by P of A. Yeah, exactly. Right, that is exactly what this division by P of A is. It's saying, like, you've renormalized things to say only A has occurred. So that's what we're going to divide by, right? That's kind of the idea there. So the probability of B intersect A is 3 divided by what? Just very quickly, B intersect A. No, not yet. Just B intersect A. So we don't want to divide by P of A yet. So if I just said, what is the probability of the first die being odd and the sum being equal to 6, right? No given that, no conditional, right? 36, right? Because I haven't done the conditional probability yet. So I'm just saying right now, this is kind of like, if last week sort of stuff, right? Like this is a question that I could totally ask you on your term test. Yeah, no problem. I'm just, so we're clear. This is totally a question I could ask you on your term test, for example, right? Because that's not conditional probability. And so that's okay. And then the probability of A, well, we would just have to write A out, right? So the probability of A is maybe let me write A out. So where we sum to 6. So again, we can just go through and write them all out, right? 2, 4, 3, 3, 4, 2, 5, 1. And so the probability is 5/36, right? So if I plug those into here, I get 3/36 divided by 5/36. And that gives me 3/5. Right? So we get the same answer regardless of whether we do it this way or not. Now, everyone, I should make an important note here about this chart. Okay, so you can see this chart is very nice, right? Because it does give you the ability to immediately say what your answer should be without having to write a whole bunch of stuff down. I was just able to circle some stuff and be like, yeah, the answer is 3/5. This only works if the event space is equiprobable, right? So if one of these die were loaded and came up, let's say that 2 came up more often than all of the other numbers, then this chart would not give me the right answer. Does everyone understand that this chart is only going to work if the probability of any of these events is equal? And the moment that I load one of the dice, or in the previous question, if I had an unfair coin, then I would in fact have to do it the algebraic way, okay? The chart only works if everything is fair and equiprobable. Will you get a question with loaded dice? You 100% can, right? Like that is absolutely a possibility. And there are examples of these sorts of questions in the exercises. And in fact, we might have one in these poll slides. I don't think we're gonna do one today, but you definitely can get a loaded dice question, okay? So just be careful about that. And in fact, what you should do if you get an opportunity, and you want to study, like let's say that you really want to study even for the term test, or you really want to understand this material well, is make up a loaded die yourself and then redo this question, right? So let's say that you create a die that comes up with your first die comes up 2 half the time, and then all the other numbers show up an equal number of times after that, probability 1/12 or whatever it is. You redo the question and see if you can get the new answer. And then if you have trouble with it, throw it on Piazza, right? Now for the other way isn't too bad because the probability of A given B, right? So that you notice the numerator is the same here, right? So we don't have to recompute that. All we need to do now is compute the probability of B. But what is the probability of B? So remember, B is the first die is odd. So what is the probability that the first die is odd? It's just a half, exactly, right? Because it's independent. And so, wait, Curdy, so I'm not certain. Can you explain 3/36? Because then maybe I can help clarify what happened there. Yeah, so how many times does B occur? So, I mean, if we draw B here, maybe let me draw it in yellow. This is B. Right? Exactly, yeah, 3, 6. And alternatively, what we know is that, again, rolling the first die is independent from the second die, right? So the probability that the first die is odd doesn't depend on whatever the second die is, doesn't depend on the sum. It's completely and totally independent from those events. So it's just, what is the probability that when you roll one die, you get an odd number come up? The answer is 50-50, right? Because there's 3 odd faces and there's 3 even faces. So this is 1836. So Curdy, does this make sense? Like there's 18 possible events here, and there's 36 total possible. So if you want to kind of do it this way, it's a half. Okay, cool. And so that gives us a 6th, right? Is everyone cool? That makes sense? Okay, so I strongly recommend that you redo this question, but you redo it where you change A So instead of right at the top of the screen where it says A is equal to the sum is 6, I want you to change it to the sum is 7 and redo the question. Okay. And I mean, if you want more practice, change it to some other things. Maybe add in some variation. Maybe change B to like, oh, the first I is at least 2 or something like that. And there's a ton of these questions that you could play with and get really, really good at, right? So there's plenty of opportunity here for you to practice just by changing things. But really, do the sum is equal to 7 and redo the question. And you're going to find something very interesting happens that only happens with 7 that we kind of talked about last week, right? 7 is a really special number when you talk about the sum. Okay, so that's something to do, something to keep in mind. Actually, the next poll question is that. I'm not going to do it, but you can see here, this poll question is precisely that, right? Let A be the event that the sum is 7, redo the previous thing. But, ooh, yes, I want to do this one. This was a term test question in the past. So there was a year where this was the term test question that they got for conditional probability. And it actually had multiple parts, right? But I didn't give it to you. Sorry, Aziz, were you going to say something?
I was going to say, I remember marking this question.
Right, there you go, right? Okay, so some of you are doing very well so far. And again, just like the previous question, if you finish this and you want to do a challenge one, again, switch the conditional probabilities, right? So this question is the probability that the sum of the values is 4 if neither of the shapes is a circle. So do the opposite. What is the probability that neither of the shapes is a circle if you know that the sum of the values is 4? Right? That's a fun one too. Give that a shot. Okay, so 30 seconds here, because there's kind of one last one I want to do after this. So we need to go through this one a little bit quickly. Okay, so let's take a look. So we said that C is the correct answer. Generally, that was kind of the consensus we came to, and absolutely C is correct. So good job. And so, first of all, let's label things as being like C1 is circle 1, circle 2, square 2, and square 3. Like, I think that's a nice way of referring to things. And then we have A is the event. What do we want? The sum is 4. And B is the event neither is a circle. And as kind of was pointed out, right, so, I had a direct message here. We want the probability of A given B, which is the probability of A intersect B, given the probability of B. And I had someone in a direct message make this astute observation. It was a very good observation. Once we know that B has happened, because we're asked to find the probability of A given B, then basically we can just ignore the circles, right? Like this question, the circles are basically useless. They don't actually tell us anything because B is the event that neither of the shapes is a circle, right? So we're told ahead of time, neither of the shapes is a circle. So you can throw them out and you can completely ignore that. And you can basically do the question that way. So let's write out B. Okay, what is the collection of events where neither is a circle? Okay, like how many events are there? Or if you can write them out, go ahead and do that. What are they? And you can do them one at a time if you want. I assume someone's like busy writing them all up. Neither event is a circle, Brandon. That's both are circles, right? Okay, yeah. All right. So we got some S2s, S2s, S2, S3. What else? S3, S2, absolutely. S3, S2, and S3, S3. Perfect. So as a class, right, we kind of crowdsource that. Perfect. And then which of these sum to 4? Oh, yeah, dot. Perfect. Yeah. So yeah, only the 2, 2, right? This is the only one that sums to 4, right? The others sum to 5 or 6. So just looking at this, what should the probability be? Like, what is the yellow thing divided by the total number of things in B? Yeah, should be 1 out of 4. Right? And again, that works because equiprobable, okay? If the probability of choosing one of the squares was different than the probability of choosing one of the other square, we'd have to be a lot more careful about that, right? This works because equiprobable. I cannot emphasize that enough. But again, let's say that we didn't see this and we kind of wanted to go through the motions. So, we've already done B. So we know that, right, in our non-intuitive way, we know that the probability of B is what? So if it just said, what's the probability of B? What would that be? Not, okay, so here's another question. What's the total number? What's the total number of events possible, period? Okay, so there's 4 out of how many? I think I've seen every fraction. Oh, and thank you, 16. Yeah, I'm saying counting everything, right? Like including circles and squares. What is the total number of events possible? And it's 16, right? Because you have 4 options for the first thing, you've got 4 options for the second thing, right? So maybe I was a little bit unclear about that, but yeah, it's 4/16. And then A intersect B, right, is both are squares, or let's say neither are circles, which is the same as both are squares, right? Neither are circles, and the sum is 4. Okay, and can somebody tell me what are the events in here? S2, S2, and that's it, right? That's the only one. Right, so what's the probability of A intersect B? Right, how many? It's, yeah, 1/16, exactly, right? There's one possible outcome divided by 16 total possible outcomes, exactly. And so what we would get is the probability of A given B is the probability of A intersect B divided by the probability of B. So that's going to be what, 1/16 divided by 1/4. So that's, or sorry, 4/16. So that's 1/4, right? Which is again what we expected it should be, but yeah, exactly. Okay, so I got a direct message saying, how did we calculate the total number of possible outcomes? So these are the 4 things that we can choose from, right? And we were told that repetition is allowed. So we have to choose, we've got 2 boxes here to fill, and there are 4 options for this box. And then because repetition is allowed, there's 4 options for that box. And now we're done, right? So it's 4 times 4 is equal to 16. Cool. So no problem. And again, everyone, if you want more practice, what you should do is change one of the conditions, say like maybe repetition is not allowed. Try and repeat the question. Obviously, in that case, the question is kind of silly because you can't have square root 2 square root 2. So, change some of the events, change whether repetition is allowed or not allowed, and then give it to a friend, like give it to somebody else in the class, let them solve it. And if you both get the same answer, it's probably right, right? And then if you guys get different answers, you can fight over it. You can try and sort it out. You can throw it on Piazza. That would be a really cool thing to do. That's a really great way of studying. Okay. So, and I know this stuff, isn't for what we're going to do on the next term test, but same stuff, same story with that stuff as well, right? Take a question that we did in the pools, twist it, modify it a bit, give it to somebody else in the class, say, hey, can you solve this? Tell me what you got. Compare your answers. If your answers are the same, great. If your answers are different, fight over it. Try and convince each other that your answer is correct. And then if you don't know, post it on Piazza and be like, hey, we made up this question. Can someone tell us who is right? Yeah, 4/16 is a quarter. Yeah. Yeah, that's true, Aruba. Because that's A intersect B. So A intersect B was 1/16, right? This was the numerator. And then this one was the denominator. Is that? Yeah. Yeah, no problem, no problem. So, okay, I don't think, unfortunately, we're going to have time to do the last one. Maybe let me just show it to you. And then again, if we really want to do it in like office hours, we can, but I don't think we will. But this one's really nice. Yeah, we could do it in office hours, and then I can, I record office hours. So even if for those of you who have to run for whatever reason, the recording is up. This is real data. Okay, these are the actual numbers from 3 or 4 years ago. Okay, so the cool thing about this question is with the actual data that we were given from 2017, 2018, whatever year it was, we can figure out what is the probability that a student passed the course given that they failed the first term test. Okay. 27, yeah, 27 students did have a rough time. And you can see if you got between 0 and 20 on test 1, none of them scored but higher than like none of them passed the course, right? See, Daniel? Yeah, so 50 is a pass, right? We will include a 50. So here, let me post it. We'll do it as a poll. We'll do it in office hours. For those of you who have to run, obviously run. I'll keep recording so you can come and you can try this one on your own.
So I was gonna say I'm gonna head out here to
Yeah.
open the door.
Yeah, for sure. See you later, man.
See ya.
Okay, that made it worse. Let me see if I can maybe zoom in on it a little bit. Does not like me zooming. Okay, so hopefully you remember what the question is. How's that? Is that a little bit easier? Yeah, maybe let me put in the chat what it is that you're trying to do, right? So probability that pass the course given that failed first term. Oh, that's true. Here, let me try and scroll down. And then that unfortunately cuts off the total, which is very, okay, hopefully that's doable. And yeah, if you're doing this on your phone, this is probably impossible, right? Like there's no way you're gonna see the table, but hopefully the screen's big enough. Okay, so let's say 30 seconds. Don't. I mean, like, there is obviously a correlation between doing well on one test and doing well on other tests, but also the course is fairly different than what it was 3 or 4 years ago, right? So I'd be a little bit hesitant to extrapolate data from this table into our class. But again, that being said, if you did, you know, if you consistently do poorly on tests, you probably won't do well on the final grade, right? Like there is that correlation, in part because those are definitely not independent events, right? Your grades on your term test 1 directly influence your final grade. Those are definitely not independent. Yeah, that would be weird. Okay, so yeah, the class is B, and yeah, B is the correct answer. So that's awesome. I'm just going to copy this table so I don't have to rewrite it all out. So just give me a second. Whoa, that's not the question. There we go. All right. So here is our table. Okay. So we want to know the probability that you pass the course given that you failed test 1. So let's let A be you pass the course. Or sorry, given that you, what are we trying to do? Pass the course given that you failed the first term test, right? So B equals failed term test 1. Okay. So what is let's see, what do we need to compute? So we need the probability of A intersect B. So that's the probability of A intersect B divided by the probability of B. Okay, so we need to compute the probability of A intersect B and the probability of B. I hope you're all in A, right? I hope you're all in A. And of course, though, like passing is not good enough for most of you, though, right? I think most of you want that 63. So it's a little bit more than pass. So that's a different number, right, to compute entirely. Okay, so let's maybe start with the probability of B. So what is the probability that a randomly selected student, failed term test 1? (210 out of 56). And how did you get that number? Sure, yeah, absolutely. So basically, what we want to say is, so this is the blue stuff. These are the students who failed term test 1, right? And you want to add up all those numbers. Exactly, Brandon, exactly. So you want to add up all those numbers. And Curdy, as you kind of point out, those numbers are actually, it tells you what the sum of each row is right here, 27 plus 71 plus 112. So if you go and you add those all up, you would get 27 plus 71 plus 112 divided by 5, the total number of students. So that gives you 210 over 560, like that. Okay. Now the probability, I still want my chart. So the probability of A intersect B, maybe let's draw that in green. So the A intersect B is what? Okay, yeah, sure. So let's look at this. So for example, this element right here says these students scored between 60 and 80 on their term test, right? So if we take this data and move it over here, and this data and move it down here. So this student scored between 60 and 80 on their term test, but failed the course, right? Because they got between 40 and 50 on the final. Does that make sense? Yeah. Yeah, so the left, right, the thing in the left column is how they did on their first term test. And then the thing on the right is, how they did on the final. Okay, so if I want to know A intersect B, so those are the students that passed the course but failed the first term test, like where in this table is that? I don't know. Curdy, maybe those are the numbers. I'm not 100% certain. Okay. So let me see what Brandon says. So the first 3 rows, last 3 columns. Okay, yeah. So does everyone agree that these are the students who failed the term test but passed the course? Everyone agrees? Okay, so we have to add those numbers up. And if we add them up, what do we get? So Curdy, maybe this is your 55 and stuff. I don't know. Oh, okay, sure. So yeah, if we add those numbers up, I also got 81, right? So I get is equal to 81 over 560. So now if we divide those things, so we get the probability, this is equal to 81 over 560 divided by 210 over 560. That gives us 81 over 210. And that works out to be about 38.6%. Right? Can I just write the answer as the total of students passing the course divided by the total students that failed term test 1? Well, I don't think that ends up working though, Jeremiah. So we could try that. So the total number of students who failed term test 1, so we still get 210, right? And then the total number of students who passed the course, so the total students who passed the course is actually this thing. Right? And notice that that's different than what I had drawn before, right? Which was only this thing. So it'll actually give you a different number. Does that make sense? And this is the whole point about conditional probability is we've assumed that we're already in the blue rectangle. So we don't want to look outside of the blue rectangle. We only want to look inside the blue rectangle. And this is what I'm saying, right? You remember when we were doing the dice table and I said, okay, we look at the given that and we assume that the given that has already happened. In this case, the blue is the given that. We've assumed that they failed the first term test. And now we want to know, right? So now we're in the blue rectangle. And then we want to say, of the students in the blue rectangle, how many of those students passed the course? And so we have to look at only the students who passed the course in the blue rectangle, right? Not overall, not everywhere, but only in the blue rectangle. And that's how we get this number. Yeah, sure. Yeah. And that is effectively what we did, right, Jeremiah? Like, you can see by my picture, right? I computed the green stuff, which is the students who failed, but were in the blue rectangle divided by the blue rectangle. And yeah, those work out to be the same thing. Again, because in this case, the probability that I choose a student is assumed to be equiprobable, right? I choose all students with equal probability. Okay, so does that make sense? Everyone understands that? So it's possible that I give you a table as well, and you can use that in order to try and sort out information like that. So I think that's kind of an interesting thing. And like I said, this is real data, right? So we can kind of infer stuff from that. And I think this is a nice thing because it does give us some sort of indication about, probabilities and, how term test 1 can affect your probabilistic outlook on the course. Now, again, we have to be careful about interpreting this data for a couple of reasons. In this year, there were only 4 term tests and none of them were dropped. Now that's different than our year, right? We have 6 term tests, so each of them are worth less, and your worst one is dropped, which means it tends to be a little bit more forgiving in terms of the problems. Our term tests are only 3 questions long. Their term tests were, I think, 5 long answer and 10 multiple choice, right? So that was very different. So that is something to keep in mind. Hala, are these questions uploaded? Yeah. And I'm pretty sure I uploaded last week. So right? They're in the readings, right? So at the bottom of the reading for each week, it says polls and answers. And if you go and check that out, you should see, I think I've kept them all up to date, but if not, please point one out and I will, upload that as soon as possible. But yeah, they are uploaded. And so you will be able to see the answers, but I usually upload them on Fridays, right? Like once all the classes are done. Yeah, no problem, no problem. Okay, so give me a couple minutes. Just again, you know the drill. Do my typical stuff, fill my water, yada yada yada. I'll come back. We'll answer all the questions that you have prior to the term test. I'm sure that you have lots. So go ahead, try and get them ready. And like I said, I only need like 2 or 3 minutes. I'll come back and I'll answer all your questions for you. Okay, so I'll be back in a second. Okay. All right, so hold on. Let me just kind of sort through my messages here. Curdy, explain about loaded dice. Sure. So we can make up an example of a question which does that. Just give me a second. I'm just waiting on a response to a direct message that actually came before you. Cool, cool, cool. Thanks. So I'm going to assume this is okay as long as I kind of keep the person anonymous. And okay, yeah. So basically it was, how can I, do better on term tests because, maybe your performance hasn't been doing as well as you'd like, and, whatever the case might be. Like and I'm certain there are lots of students in this class for whom this is true. And if those students are watching this recording at some point in the future, I hope that this advice does them some good advice. I hope that it does them some good as well. So a lot of students, for example, and this is the hard thing about first year, right, is that you're kind of trying to adjust to university and the way that you study for university. And I think especially university math is different than what a lot of people would have done in high school. So first of all, let me point out that we do have a couple of resources. Let me pull them up here. Yes, stop sharing. Okay. So note, I think that some people don't even know that this exists, but in our syllabus, we actually have There's something over here in other, and there are a couple of things here. So first of all, there's a page called study tips, and then common mistakes and how to avoid them. So I'd recommend everybody, give those a read if you haven't done them, first of all. And it kind of gives, some very bland, very generic advice, but things that you can do, right? So like I say here, make a practice list where basically you go through all of the questions that you think will be related to the test. And you just write them down on a piece of paper. Don't do the solutions, just put them down on a piece of paper somewhere. And then just go through them, right? Like once you've got them all compiled, just start checking them off, go through them. If you get it 100%, great, you check it off. And if you don't get it, you put a little star beside it. You maybe look up solutions, whatever, but you didn't get it on your first try. So you know now that this is a problem that, this is a question that you've had problems with. And the star reminds you have to come back and you have to readdress it some other time. One of the great mistakes that students make is that they work through a problem, and then when they get stuck, they look at the solution. And then having looked at the solution, they then are able to finish the problem. And they say, okay, I now understand this. And then the same question or a question very similar shows up on the test, and they get stuck on it in exactly the same place. And a lot of students are very frustrated by this. They say, well, I know I studied this question. I solved it when I was on my own, and then the test came and I wasn't able to do it. And maybe this is something that's more in person than online, but they will often say this is a result of test anxiety. Okay, sometimes it is, but a lot of the time, if you don't practice getting over that hump yourself, then you won't be able to do it on a test. So this is why solutions are dangerous, right? Do you understand what I'm saying? Like you walked up to the you hit an obstacle, you use the solutions to get over the obstacle, and then you finish the race. And then on the test, you hit the same obstacle, but you never practiced getting over the obstacle on your own. So you hit the same obstacle and you can't get over it, right? And that's a problem that a lot of students have. So when you make this practice list, if you get stuck on a problem and you can't solve it, you put a star beside it, and then you look at it again the next day, right? And this is why you have to start studying ahead of time so you can spread this out. Because the next day, what you probably will find is when you redo the question, you'll get a little bit further, but then you'll get stuck again. And so you put another star beside it. And then the next day you get it, you try it again, you get a little bit further. And then hopefully on that third day, you solve it. You're like, yes, I know how to do this question now. And you've practiced getting over that obstacle on your own. And then that way, when the test comes, you know for sure how to deal with it, right? So this is what I'm saying. You have to be really careful about solutions. Solutions can convince you that you know something when you don't actually, right? And so in that case, solutions can actually hurt. One thing that I recommend as well is designing a practice test for your friends. And of course, maybe the problem is you might not have any friends in the course, which is, again, not an indictment of any of you. It's, we're online. It can be a hard thing to do for sure. But this gives you, when you design a test for a friend, it actually strengthens a couple of things. First of all, it gets you thinking about what a test should look like, and what sort of questions make good test questions. And then the great thing is that if you give your friend a test, hopefully they will give you a test as well. And what you should do is write it as if it was a test, right? Like, don't, sit down, spend like an hour or two just focusing on that question. Only give yourself access to things that you would have access to in a normal test, and write it, right? Because test writing is a skill. Period. It is a skill. It's not something that just like you could know everything that there is to know about the subject, but if you're not a good test writer, you're not going to do well. So how do you get better at writing tests? Well, you practice writing tests. But the problem for most of you is that the only time you practice writing tests is when you're writing a test, right? Do you see what the issue is? So sometimes if you want to strengthen that test writing skill, you need to practice it in an environment where there's no stakes, right? Just like when you play sports, you'll practice in a no stakes environment so that when the game comes, you're in the, you've trained. You don't want to be learning your mistakes in game time, right? When there are stakes involved. So practice writing tests by making a test for your friends and having them make a test for you. The future I recommend you read this one. This one probably doesn't apply to the tests as much as the final exam. That's something to keep in mind. Study groups are absolutely a thing. And yeah, I mean, totally, that's true. Like time pressure on tests is a major factor. And I don't think it ever should be. Like I don't think it's a learning objective for almost anyone. But it can be an impact, and students do sometimes freak out about that. Study groups are incredible, everyone. Like, really, I cannot emphasize enough, and I think I've tried to say this at the beginning of the year and multiple times throughout the year. You should not be trying to do this course on your own, right? Like, I'm not saying cheat. I certainly don't want you to do that, but you should be working on your assignments with friends. You should be studying with friends. Don't write your test with friends, but study with them. Because what will happen is you 100% can get stuck on a concept, and you're just like, you sit there, you're by yourself, and you're like, I don't get this. And you go and you check the notes and you still don't get it, right? And you just get this immense feeling of frustration. I think you all know what it's like. I felt it too, right? Where you're just like, I don't get this. Like, I don't know what to do. And you just get angry and frustrated and you get upset. Exactly. Yeah. So the thing is, that doesn't do you any good, right? When you get to that level of frustration, you cannot learn anymore. So what you have to do, there's a couple of ways that you can deal with this, and this is actually related to this thing as well, okay? One thing, though, is having friends, because when you have a study group of, and again, keep it relatively small, okay? Don't have a study group of 50 people. That's not going to do you any good. But a study group of 3 to 6 people is, when you get stuck, chances are somebody in your group is like, understands it and can explain it to you, right? And or at least maybe understands it a little bit better. And then you guys can play off of each other, and together you can figure out what the concept is. You just need somebody to bounce ideas off of. And then same sort of thing, you might come to a concept a little bit later that you understand really well, or just better than one of your study group friends, and you can help explain it to them. And it's not just a situation of helping each other. That's not just what it is. The act of explaining a concept to somebody makes you understand it better. Okay. And I think I was like possibly talking to Curdy about this, or maybe Kayla, I don't remember who of you it was, but it was this rubber ducky thing I was talking about, right? Which, where you put a rubber ducky on your desk and you explain the problem to the rubber duck. And then by virtue of having explained it to the duck, you solve the problem. This is a real thing. Okay. And we do it all the time in academia. Is that the act of explaining a problem to someone can help you solve it. The act of helping someone understand a concept can actually cause you to learn something deeper about the subject. So exactly. So not only have you made sure that there are a couple of other people in the class who can help you when you get stuck, the act of helping people makes you a better understander, makes you a better learner, makes you a stronger student. Okay. So it's not just like, oh yeah, I show up, I explain these concepts, I don't get anything out of it. Even if you think that you understand everything and you go to a study group and you're doing most of the explaining, I promise you, you're going to find that you understand things better by virtue of explaining them to a student. And the fact is, this still happens to me. There are some times when students come to me in office hours or during lecture and ask me a question. And when I'm looking for different ways to explain it, or they come up with like interesting, like maybe they got it wrong, but in an interesting way that I don't see immediately why it's wrong, I learn something. Sometimes I actually gain a deeper perspective of a problem because I'm explaining it to a student. And this still happens to me to this day. Okay, so I promise you there is value in helping teach your friends and colleagues about that. But it can only happen if you're actually in a study group. And I know that's harder in an online environment, I really do. But you should, I still think, aim for it. And then finally, take breaks. Okay, I can't emphasize how important this is. I think a lot of, if you find yourself in that frustrated state that I was describing earlier, you're done. Okay, I don't care about how hard you're interested in working. If you're in that frame of mind, you're not learning anymore. So to sit there, and it can feel frustrating because you're like, oh man, the test is coming. I feel a lot of pressure. I need to keep working on it. It doesn't matter. Your brain is not in a state where you are capable of learning. When you get to that point, you have to stand up and you got to go do something else. Okay. And it doesn't matter what it is. It doesn't matter if you just go for a walk, go for a 10-minute walk, outside, get some fresh air, come back, go for a nap, go for a 15-minute nap. Seriously, naps are phenomenal. Go play 10, 15 minutes of a video game if you have one that you can kind of put down, right? Like assuming you're not, if you start playing, not can play for like 4 hours. If you can play 10, 15 minutes of a video game, just take your brain off of it, try and relax a little bit and come back and look at your work, then that it does wonders. If you're in a frustrated state of mind, you will not learn, period. Okay. So you have to catch yourself when you're at that point, walk away, go do something else, kind of relax, bring your brain back down to a state where it's ready to learn, and then attack your problems. Okay. Super critical, super, super important. And seriously, naps are phenomenal. I can't stress how useful naps are for relaxing and actually solving problems. You'd be surprised at how many problems you can solve in your sleep. Okay. So this is kind of generic stuff. And like I said, you're all going to be different, right? Like you're all, you have little idiosyncrasies or ways that you've learned, ways that your neural pathways have developed. And some of these will work for you, some of these won't work for you. And some of you are going to find things that are completely and totally unrelated to anything that's written here. And part of the first year experience and part of why first year is so tough is you're figuring that stuff out, right? This is the first time where it really matters and you're figuring it out. So that can be tough. And I totally understand that. But here are a couple of things that I know have worked for me and have worked for a lot of my colleagues. So it gives you a place to start, and then you can see what works for you, what does, and then experiment with that. Okay. The other thing here is common mistakes and how to avoid them. So this is incredibly important. So I think a lot of you out there probably say, I'm not good at math. I've never been good at math. And you can see what I say here is that, like, first of all, that you can't have that attitude. You have to have a growth mindset. And it's easy to kind of enter into that pessimism. And I'm not saying math isn't tough, okay? Anyone you meet, whoever tells you, I say this too as a mathematician, if you ever meet somebody who says math is easy, they're full of crap. They just haven't done enough math, okay? Math isn't easy for anyone. So nobody's good at math. Right? But that doesn't mean that you can't learn it. And you have to believe that you can learn it. There's an incredible amount of studies that show that having a growth mindset is so, so important to actually learning, right? You have to believe that you can learn in order to actually learn. And it's okay. It can be hard. That doesn't mean that you're not going to learn it, right? So have a growth mindset. Yeah, absolutely. And it's like anything, right? Like when you look at a weightlifter, for example, they don't lift light weights, right? If you want to get bigger, what do? You lift heavier weights. And does it hurt? Hell yeah. Is it hard? Hell yeah. But that's how you get better, right? And there are going to be people who are like, yeah, I'm no good at lifting weights. And say, well, okay, maybe you just haven't been approaching it the right way, maybe not right with the right tutelage or the right coach or whatever the case might be. It's not easy for anyone. It's not supposed to be easy, right? But you have to believe that you can learn. This is a big one. I think this is actually one of the interesting things that is less true in an online environment. In person, I think people are a lot more afraid of looking dumb. Like people are less hesitant to put up their hands in class and ask questions because they're afraid that their questions are dumb. But one thing I've noticed teaching online is students are much more likely to engage in the chat and ask questions that they probably wouldn't ask in person. So this one might not necessarily apply. But the point is, you're here to learn. To hell with everyone else, right? Who cares if anyone in this class thinks that you're stupid? Because I promise you one thing. First of all, I don't think you're stupid. I will never crap on you for a question that you ask, ever, right? Because my job is to teach you. And I can't, if you say, come to me with a question, I'm going to help you with that question, right? That's the point. So I'm never going to crap on you for that. And two, who the hell cares what everyone else in the class thinks? You're here, you paid a good amount of money to be here, you're going to learn. And if you've got a question, you should ask it, right? Who cares what what Joe Schmo on the other side of class thinks about you? You're never going to see them again in real life, potentially literally never. And then if you do, again, who cares? What do they mean to you? Anyone who judges you for that isn't worth your time anyway, right? Thanks, Jeremiah. Okay, so kind of keep that in mind. Don't let pride get in the way of your education. And I say this as someone who 100% let pride get in the way of his education. I was totally that guy, who, went through high school and was definitely one of the smart guys. And when I was in university, I was afraid to look like I wasn't the smart guy. And of course, I was an idiot too, like I was peacocking in first year and tried to make myself seem smarter than I was. And then, of course, I couldn't make myself look dumb. That's all stupid. Don't do that sort of stuff, right? Who cares? Just ask the question. I say math is not a spectator sport. You have to actually do it. I hope that you are doing it the way I've tried to design the class so that you are all engaging. You're actually doing math. You're actually solving problems. And again, I've tried to design the class around this. But if you are one of those people who, for example, isn't trying the poll questions, and I know that there are some of you out there, maybe not in this group in office hours, but during the main group, there are some people who just come, watch, hit a poll answer at random. please don't do that. I want you to engage. I want you to actually try, because that's how you learn, right? You actually, thank you, Doug. Yeah, we worked hard on them. And, to actually engage in those problems, because I'm here and can help you, right? That's the entire point. Like, I want you to make mistakes so that you can ask questions so that I can help you, and do those sorts of things. Okay. And then there's some little bit, I guess the only thing really to use here, failing to change when things are not going well, right? So again, at this point, you've written 2 term tests, and if your 2 term tests are not as good as you would have liked, it's time to start saying, I'm doing something wrong, right? And I need to readdress and consider how I'm approaching this course, because it's probably not going to get better. It's probably only going to get worse. And hopefully you're seeing improvement. Like, if you are making changes and you are improving, that's phenomenal. That is still what we want to see. But if things still aren't quite where you want to be, you always should be looking to improve, right? And when you get to a point where you're happy, phenomenal, that's great. But again, don't be one of those people who just sits there and says, oh, I just had 2 bad tests, the 3rd one will be better. No, as soon as something is wrong, actually take the bull by its horns and start to do something about it. And one thing I do see is students kind of fall into this thing where they believe that they can't fail. And I don't know if that's true for any of you, if you believe that you cannot fail, but I have seen students have this mentality before, because in high school, for many students, it is impossible, right? Effectively, if you show up and do a minimum amount of work, your high school teacher will pass you. But unfortunately, that's not how it works here, right? And it is very easy and very possible to fail this course, and any course really, just because you didn't, right? Like, hard work has nothing to do with it. You could work super hard, but if you get all the questions wrong, you fail the course. So, don't make the mistake of falling into that and believing that it can't happen to you. You don't want to learn that one the hard way, right? Okay, yeah, so I have an interesting question, which is, how do I move forward to address the problem of thinking that there's no way to get better grades after not doing well on a couple of the term tests? Is a constant mind block sort of thing. So this is another point. Let me bring this one up. This one's not written down, but this brings up a good point. It's definitely hard to get past that block, right? Once you've done poorly a couple of times, it's easy to get into a kind of like depressive, oh man, I suck, I'm never going to do better sort of thing. And of course, that is a defeatist attitude. It ends up becoming a self-fulfilling prophecy. That's a huge issue. So one of the things that, first of all, you're going to want to do, if you've done all of these things and none of them are working, you need to seek one-on-one help with me or another instructor. And TJ right now is the only one of us who has one-on-one office hours, unfortunately, and I might start setting up one-on-one office hours. We'll see in the future. But basically what you want to do is you want to take your term tests to a TA or to a professor, ideally a professor, and say like, hey, I didn't do well on this test and I'm not 100% certain why. Can we go through this test and can we figure out what went wrong? Right. And I mean, you should try and do this yourself, right? But if you really don't see it, take it to a professor and we can help. And the main way that students do poorly on tests, in my experience, is one, they don't read the question, right? So they don't read the question carefully. And that's something that I think usually does happen in tests where time is more of a factor. I'm hoping that you're all reading the questions very carefully in a 24-hour test, but in a time factor test, people tend to not read the questions very carefully. Number 2, students make stupid mistakes. And I don't mean stupid as in you are dumb. I mean, like you said 2 + 4 was 8, right? Sort of thing, like those sorts of mistakes. Those are dumb mistakes to make. And I make them all the time. And I'm certain you've seen me make those mistakes, right? Where I switch E and F or do something like 2 + 4 is 8. Those mistakes are often fixed by going slow, taking your time, and again, not rushing. The majority of those mistakes come from just rushing, right? So those are how we can fix those. Is the issue that you're just not studying the right way? Is the issue that you have fundamental issues with understanding the course material? Basically, what we want to do is we want to look at a term test and we want to say what went wrong, right? And that way we can diagnose the issues that you're having. Once we diagnose the issues that you're having, we can try and say, okay, well, here's a couple of things that we can do to try and address those problems. And then what you should hopefully see is that the next term test, it's not going to be an overnight thing, right? You're not going to go from getting 30% on a test to getting 80%. That's not going to happen. But our goal is to get you from a 30 to a 50, right? And then on the next test, maybe a 50 to a 60, 65. And then the next test, a 65 to a 70, something like that. And if we can see that sort of growth over 3 or 4 tests, that's phenomenal. Like, as far as I'm concerned, that's best case scenario. And it does happen. Okay. It happens every year where we get a student comes in first test, they get like a 20%. And by the last test, they're getting 80s. And it's because we were able to diagnose what they were doing incorrectly and then, work together in order to bring the student up and fix their habits and get them to a point where they were able to succeed. But part of that is you need to be able to have that self-reflection. You need to be able to look at a test and say, what went wrong? What did I do wrong? And then how do I fix it? And if you can't do that on your own, then you have to come see a prof so that we can help you with that. Because that's part of our jobs too, right? That's what we need to be able to do. So don't just, right? This is what I'm saying. When you get a test back, don't just be like, look at the mark, maybe look at some of the feedbacks and throw it away. Look at it and say, what mistakes did I make? And how do I improve on those, right? And you have to be doing that for every single test and looking for those opportunities to improve. Okay. Brandon, I think in your case, that's not necessarily a bad thing. It's just you have to make sure you don't get down on yourself when you fall through that floor. Right. So I have this question from a direct message, which is, how do we do this, right? Like, how do we schedule one of those meetings? So right now, TJ does have one-on-one office hours. I recommend that you do it with him right now. And if it starts to become too much, we can try and set up, you can try and email me and set up and see if we can find time. Jordy, I think, also will do one-on-one TAs by request meetings. Yeah, so those are the 2 people to ask right now. You can try asking me, but it depends on the year how busy I am. And I tend to be more busy than those other people, but we can try. Ahmed, I mean, that is a great improvement. I don't think, even though you might not be happy with that second grade, the reality is that if you increase that and you're able to make that same jump on term test 3, then that's phenomenal. Do you know what I mean? Like, I would be ecstatic. If you did that much better on term test 3 than you did on term test 2, then we're in a phenomenal place. But that being said, what I still want you to do is I want you to go back and I want you to look at term test 1. I want you to look at term test 2. And again, really be honest with yourself and say, not just your studying, but look at the test itself and say, why did I lose my marks here? Did I make a dumb mistake? Did I not understand what was happening? Did I not read the question? Ask yourself those questions and then do that for every single question. Do it for all 3 tests and see if there's a common theme, right? Is the common theme that you're just not reading the question? Because if it's true, that's such an easy fix. Do you know what I mean? But if the issue is that you don't understand something is fundamentally an issue, then we can, we have to address your studying, for example, right? Oh, Theodora, that's phenomenal. I would love if you posted that publicly. I don't know if you're comfortable doing that, but I think it's really great if your classmates know that you can do that and that it has been successful for you. So if you don't feel comfortable doing it, don't worry about it. But that is a great thing that I think the class would love to know. Zoe, this is an interesting question. So there's and kind of it's this common question of it's this question of, if I was struggling with stuff from linear algebra, what do I do about it now, right? Because we're on a different subject. And when you have to make the call between doing new stuff and doing old stuff, how do you make that decision? That's definitely tough. So my recommendation here is, do the new stuff. And then if you get time, go back and do the old stuff, right? What you don't want to do is sacrifice your future marks so that you can go back and try and fill a hole in the past. Kind of what you need to do at some point is cut the losses, restart, and then just try and not fall behind again. But if you ever get free time, go back and plug those holes from the past. Do you know what I mean? Yeah, no problem, Ahmed. See you later. And I mean, that's not optimal, but I would recommend doing that just as from a meta optimization viewpoint. But nonetheless, when you do get a free opportunity to go back and look at some of those things from the past, highlight a couple of problems that you're really struggling with. Okay, so if you're really struggling with a couple of linear algebra problems, find a couple that you really struggle with, and then again, come to office hours and be like, I don't know how to do these. I'm trying to plug this hole from 4 weeks ago or whatever. And see ya, Sam. I'm glad that it meant so much to you. But yeah, to bring questions to us so that we can help you. And because if we're trying to diagnose your issues, that can be tough to do. Students will often come to me and will just say, I'm struggling with this and I don't know what to do. And I say, okay, and I want to help. But if you bring me particular questions that you're struggling with, then I will be able to see, I'll be like, show me what you did. This is why in Piazza, right? If for anyone who's asked questions at Piazza, that one of the things we ask is, what have you tried? Like, show us what you've done. Because if I see your work, I can see what mistakes you're making, right? Like I can see your thought process, and I can see that if you're making a mistake in the way you think about something or the way you're computing something or whatever like that. But to do that, I need to see your work, right? And when I see your work, I can go in and I can correct it. I can fix it. But coming to me and just saying, I'm confused, well, then I have to start asking you probing questions to try and figure out where the issue that you're having is. And that's very, very hard. So when you're fixing, you should do this always, but especially if you're trying to fix a hole from a previous subject, bring us stuff that you're struggling with and bring us your work so we can see what you tried to do. And then we can look at it and very, very quickly diagnose what went wrong. And hopefully be able to like very quickly put you back on the right track and really speed up your fixing, right? Like that hole plugging. So that's I think sort of the idea to do there. Okay. And that's universal, right? If you're struggling on some sort of probability question right now, it's not even plugging a hole. It's the sort of thing that's going to affect you in the next test. Bring us something that you're struggling with us, show us your work so that we can see how you're thinking. And that'll make a big difference to our ability to help you. Will it remain open in December? It will. We'll probably be less responsive, Agam, but I'll definitely still answer on occasion. The TAs won't have an obligation to do it because they won't be paid at that point, but I will definitely still answer. Like I said, might not be as often, but I will. Oh yeah, so okay, and again, that kind of goes to the pride thing, right? But here's the thing, especially in office hours, I promise you there are people, and if you want, go to TJ's office hours, right? Because TJ again does the one-on-one, and so you don't have to worry about other people. But at some point, I think you just got to say to hell with looking stupid, right? Right. Yeah. But I think, you have to say who cares, right? Because again, you're here to learn, you're paying money to be here, you want to learn. And again, so first of all, my mentality is you can ask me a question from any time during the course and I will be happy to answer it because I don't care. I just want you to learn and I don't care what we're doing at the time, right? And here's the thing, especially, I promise you, any question you ask, there's going to be other students in the class who also have that question, right? And who also just don't want to ask it. But yeah, don't worry about that sort of stuff. Ask. I'm happy to take it up and to cover it, right? The only time where there might be some bitterness and resentment, if it's the Thursday before the test, you know what I mean? If it's this Thursday and the test starts at 9 and people are trying to answer last minute questions, maybe that one wouldn't be as great. But I think any other time it would be totally okay. And definitely Piazza. I mean, put it on, you can put anything on Piazza at any time and we'll go back. And I'm happy to answer those questions whenever. And if you really want those ones to be private, then yeah, you don't even have to worry about what other people think, right? But yeah, everyone, don't hesitate to ask questions about any part of the course at any time. I will be happy to answer those things. After this test, are there still office hours? I will have office hours that Tuesday. So in the half week, our lectures will become office hours. So we won't do any new material on the 6th and 7th, but instead they will be office hours. So you can come and ask questions. Is Tuesday the last class? Thursday is the last class, but Tuesday I will be here, right? So on Tuesday, December 7th, I will be in this meeting. You can come and you can ask me questions and I will do any questions that you want. So you can use that as an opportunity to catch on. Yeah, 100%. Yeah, if you have linear algebra or financial math questions, that's the time to come and I'll take those questions up. Yeah, so that's a great time and opportunity to do that sort of stuff. Okay, let me do a loaded dice question because I know there was a question about it. Yeah, exactly, up to total probability. So basically everything that would have been covered up until and including last Thursday, but nothing this week. Nothing this week is there. Okay, let me, right, so again, we had a kind of loaded dice question. So maybe let's do something like that, see what we can come up with really quick. Okay, so let's do a crazy dice. So let's have a dice. What do we want? So let's say you roll a red dice and a blue dice. Okay, so blue dice, let's say the blue dice is fair. Okay, let's say the red dice is the following. So the red dice has the following probability distribution. Let's say it comes up a third of the time if x is equal to 1 or 2. And then what do I need? So I've got 1/12 if x equals 3, 4, 5, or 6. Okay, and does this add up to 1? It does. Okay, so does everyone understand what I'm saying this? So I'm saying the probability that this dice rolls a 1 or a 2 is a third, and the probability that rolls any other number is 1/12. Okay, so this is not a fair dice, right? Because a fair dice would be 1/6 for every face. This dice is more likely to come up 1 or 2, and then less likely to come up every other number. Yes, yeah, it would be given. Okay. Okay, so we could say something like, find the probability what do we want? First dice is odd. This one's actually not going to make a difference, but probably the first dice is odd, and the sum is, I don't know, 4. Okay, so this is our event that the first dice is odd, or let's say the blue dice, not the first dice, that the blue dice is odd and that the sum is 4. Okay, so let's write out that event. So let's say, we write events as A, B, where A is the blue outcome and B is the red outcome. Okay, so let's write out this event E. What are all the ways that the blue dice is odd? So the first dice is odd, and we sum to 4. Like what are the ways that we could do that? Ah, 2-2 though, the blue dice would be even. 1-3, okay, that's 1. And 3-1. Right, okay, everyone's good with that? Okay, so our first instinct here, if everything was equiprobable, the probability of E would be 2 out of 36, right? Does everyone agree? So if E was equiprobable, then the probability of this event is 2 out of 36. Let's compute the probability of E now. So the probability of E is going to be the probability that we get a 1-3 plus the probability that we get a 3-1. Okay, and the dice rolls are independent, which means that this is going to be the probability that we get a 1 on the blue, and maybe let me write the probability that we get a red on the 3. And again, we know that the red dice is equiprobable. Damn it, why did I write B? That should be a B. So this is 1/6 for everything. Maybe let me just say this is 1/6, right, for X. Okay, so it's going to be the probability of the blue dice is 1 and the red dice is 3 plus the probability that the blue dice is a 3 times the probability that the red dice is a 1. Okay, what is the probability that the blue dice is 1? Does anyone remember? Oh, here, look at there. Right, it's 1/3. Right? It's this thing right here. So it's going to be 1/3. Does that make sense? Right, because this is the loaded die. The blue die is the loaded die. Right, the blue dice wasn't fair. It would be 1/6 if it was fair. Oh, did I say the blue dice? Oh, son of a gun. Yep, you're right. You're right. Sorry, everyone. I was screwing up. This is the red die. This is the blue die. Yep, you're right. You're right. Sorry, you were both right. And Agam, you were right with my screw up. Yeah, that was my mistake. Okay, so you're all right. The blue dice is fair, so that's 1/6. And then the probability of a red 3. One 1/12, perfect. Okay. And then we're going to add to that. So the probability of a blue 3 is 1/6, and the probability of a red 1, 1/3. Right? And we could work out what this is. This is 1/72 plus 1/18, which is what? So that's 5/72s. And yeah, we can't reduce that any further, right? So notice this is not 2/36, right? So if it were fair, it would have been 2/36, which is actually pretty close to this. But it's not fair. So we got 5/72. And so the way that we have to handle it is we really have to break it down. We have to compute these probabilities like that. And that's how we get our answers, right? So that's how we deal with loaded dice. So I got a direct message which says, what does fair mean? So fair means that all probabilities are equal, right? Like the probability of any event, like, so basically your most die that you have are fair, right? So that you roll it and there's an equal probability that any of those faces come up. Loaded is the opposite. So loaded means that one face is more likely to come up than others. And you can imagine loaded die are generally, frowned upon if you're betting with money, right? Someone will shoot you if you use a loaded die. E in this case is just this event. You're right. I could have been clearer about that. Or this event, I guess. So you're right. I wasn't as clear about that. I should have, if I was doing this as like a full solution, I would have said let E be this event, which we can enumerate as follows. Yeah. And so, and this is the same thing, right? Like all throughout this lecture, when I was like, when we do conditional probability, if you're going to look at this space and just say, oh, the probability that B has already happened, this is the number of events in that, or here, let me just scroll up. Hey, what happened to all my pretty drawings? Oh, I must have deleted them, right? So when we said, the probability of a 6, and then what's the probability that the first dice is odd, we were able to just look at this and we were able to say that the answer was 35th. If the dice are not fair, then this chart doesn't work. We can still use it, right? We can still use this to help us figure out stuff, right? Like B intersect A is the stuff that's both yellow and blue. So we can still use it to enumerate the sets, but we can't just divide one by the other. It doesn't work anymore. We would actually have to compute these probabilities using the distributions that we were given, right? So the charts can help, but we can't just see the answer from the chart if we don't have equiprobable outcomes. Okay, so anything else quick? I know I kind of ranted a little bit long about helping and study techniques and stuff, but yeah. The sum is 7 and the first die is odd. Is it because they're independent? The conditional probability is a half? Exactly. So yeah, they end up being, so what I'd like you to do is if you intuited that because you knew that they were independent, then yes, they are independent. That's why the probability is a half. But go through and actually do the computations, right? Compute E intersect F divided by the probability of F and see that it does work out to be a half. And so this ends up being another condition for independence, right? So we said E and F are independent if this is true. And in fact, if and only if this is true, right? So if the probability of E and F is the probability of E times probability of F. But notice that if we plug this into the conditional probability formula, okay, so this is just a conditional probability formula. If I now plug that into there, these two things cancel and we just get the probability of E. Okay, so another way of testing whether two events are independent is to compute the probability of E given F. And if you just get out the probability of E, that tells you the events are independent. That's the mathematical thing. But of course, this should make sense too. If you think about what this is actually saying, it's saying, what is the probability that E happens given that F happens? Well, if they're independent, the probability of E shouldn't depend on F, right? So you should just get the probability of E out. So I have a direct message here. How can you check if you're counting correctly, right? Right, how can you check your counting? Generally, you can't. And I know that that's probably not a satisfying answer. And indeed, it can be very easy to make a convincing argument about, it can be very easy to make an argument that seems correct, but is wrong for some subtle reason. So unfortunately, there is no way to check your counting answers. And you just kind of have to do it enough to the point where you get comfortable with all the sorts of arguments that you can make. And it's part of why counting is hard, right? Like legitimately counting is tough. I've had a conversation with a couple of the TAs where they're like, man, this stuff is killing me and I had to review it. And I said, for sure, don't worry about it. Like even when I reteach counting every year, I kind of have to review it a bit because I don't, some of the things are a little bit subtle. It's tough. That's combinatorics. Combinatorics is generally quite tricky and there is no way of checking your answer, unfortunately, right? Yeah. Okay, so on the previous assignment 5, it said Z had one option, but I put 3. I don't understand why it's 1. It's because you don't get to choose it, right? So if Y is, 130, the remainder of this is what? 1? Right? So once this number is fixed, you don't get to choose this one, right? Yeah, that number is forced, right? That number is forced to be correct. Mm-hmm. And in fact, this is how it works in real life, right? When you think about credit card numbers are typically 16 digits long, right? So a lot of people are tempted to say something like, oh, well, so therefore there's 10 to the power of 16 possible credit card numbers. And the answer for that is actually no. There's a bunch of different restrictions, right? The first number indicates whether you're a credit card or a debit card or whatever the case might be. But the more interesting thing is that there are actually numbers, like some of those numbers. You ever notice that if you put a credit card number incorrectly into a website, it can tell you that the credit card number is wrong before you've even done anything? And it's because there's checks, right? So for example, that last number, it's not this straightforward, but that last number on your credit card, usually what they've done is they've added up the 15 numbers that came beforehand and then outputted the remainder when you divide by 10. And so just this simple check can test whether the credit card number that you inputted was correct or not, right? Now, the actual test is a little bit more sophisticated than that, but you don't get to choose the numbers that show up in a credit card willy-nilly. There are digits that are actually what are called like test digits to make sure that the number is valid. And they're forced to be certain numbers based off of what the other numbers in the credit card sequence is, right? So that ends up being a real thing. Exactly. Yeah. The card's in a straight. Once you know the first one, great example, Brandon. Once you know what the first one is, the rest of them are forced, right? You don't have a choice of that. Yeah. Okay, everyone. So we're a little bit over 7 o'clock now, but hopefully, I hope I got through most of the questions. I know I did go a little bit on the test stuff, but yeah, hopefully that helped a little bit in the long run. Yeah, absolutely. Everyone else do gather your questions. I'm happy to answer as many as you want on Thursday. And of course, post stuff on Piazza and, we'll answer some stuff there as well. Okay. All right, everyone. See you on Thursday. No problem. Ciao, everyone.